Hello, derivatives 4, fourth class of derivatives. Right now I'm looking at page 39, which is the very last thing we did. I did this quickly, and it was the chain rule. So all of these questions here that we're looking at use the same basic concept. The idea is that if you have a complicated function, or a composite function, which means you have a function inside another function, the steps are always the same. You work from the outside to the inside. Or in other words, you do the derivative of the outside, which is usually a power rule. You keep the inside the same, and then you start again. You get the derivative of the inside again. And then you keep going through that process until you're finished, okay? But before I go into chain rule, I'm going to review the product rule. I'm going to review the quotient rule, and then we will combine it all again into the chain rule and then take it one step further, okay? So that's the plan for today. I'm going to rewind. You know, if you don't want to look at the screen, this might make some students feel a little bit sick. Just look away for a second. I'll go find the practice problems. Let's see. Practice problems, yeah, on the top of page 34. So this is page 34. We already did the first 3 practice problems, which is why we're starting on question 3. But I skipped them. Some of you might have done them already. If you have, I'm sorry to do a repeat, but I want to make sure that we're clear on all the rules. Okay, so our main rules are our basic power rule, our most powerful rule, in my opinion. And then we have the product rule, which we're going to cover right now. So when you look at a question, if this didn't tell you to use the product rule, how would you know to use the product rule? Well, hopefully it's simple because we see that these 2 brackets are multiplied, which means that they're a product. If they're a product, which means they're multiplied, then you're going to use the product rule. So we're going to just put product rule. And you, of course, need to remember what the product rule is. Do you remember what the product rule is? Because we've done the product rule and the quotient rule now. In my other class, they came up with a bit of a rhyme. FG, FG, first prime, last prime. Or FG, FG, first, last prime. In any case, FG, FG, so first and second, plus the first one's prime, the last one is prime, which means you get the derivative of the first one times the second function, plus the first one times the derivative of the second function. So I'm going to be very clear here. We don't always need to write this out separately, but I want to make sure that it's clear. Let me just write out here what the first function is. And I'm basing it on this. First, second. First function, you just take it just like it is. We're going to get the derivative of that. So what's the derivative of this? Each piece is slightly different. They use different rules. How do we get the derivative of this first one? I would hope that you remember you take the 3, bring it down in front. If there's a number there, multiply. So that would be a 9x. And then reduce the power by 1, minus 1. What's 3 minus 1? It's 2. So it'll be 9x squared. The next one, negative 2x. I'll just make a note here. If you have negative 2x and you want the derivative, it's just negative 2. For reasons we said before. Essentially, it just deletes that x. And the reason for that is because it has a power of 1. A power of 1 would be reduced to 0, which the exponent of anything to the power of 0 is the answer for anything to the power of 0 is just 1. So anyway, this just gets canceled, and it gives us minus 2. So remember, if you have for example, if you had 7x, the derivative of that would be 7. If you had negative 14x, the derivative of that would be negative 14. It just deletes the x. If you have just a single x, just remove it, is what I'm trying to say. And then what's the derivative of 7 here? That one should be very simple. That's a constant. If it's a constant, it goes to 0. It gets deleted. So I don't write it. I won't write the 0. It would be a waste of time. Okay? So derivatives of constants are 0. So it's just a quick review. That is f prime. Let's do g. What's g? Well, I'm just going to copy it from the original question. And now I'm going to do g prime. What's g prime? Let's see. G prime, g prime, g prime. 2x That's this piece. What's the derivative of 5? Well, it's 0. It's a constant. It goes to 0. What's the derivative of this one? Same idea, power rule. The 4 comes down, multiplies. It'll be negative 16, and then the power is reduced by 1. Okay, so before I move any further, I need you to tell me how we feel. On a scale of 1 to 10, how much does that make sense? Because if it doesn't make sense at this point, I need to go back on some fundamentals. 10. Thanks, Sarah. I love to see that number, but I don't expect it all the time. How do we feel about this? You all awake out there? It's 9:45 in the morning. You should be awake as I drink my coffee. 5.9, 10. It's easy. All right. Just to be clear, really, you don't need to write this down. The power rule works like this. If I want the derivative, the 4 comes down, keep the inside the same, power is reduced by 1. That would be 1. Don't write this down, or if you do, write it somewhere else. I'm just going to erase it. Remember that if there's a number in front, let's just say it's 3x to the power 4, the 4 comes down and it's reduced by 1. So it becomes 12x to the power of 3. That'll be another example of the power rule. If it was something with an x, let's just say 5x or negative 5x, the answer, you delete the x, is really what happens. That's the shortcut. Just remove the x. And finally, if you have a constant, like 15, any number, no x, just a number. Remember, a constant is a straight line, and the slope of the straight line is 0. So our derivative is just the slope, it becomes 0. So these are our rules. This is why this works. I'm going to delete this. That was just, I probably don't need to delete it. I'll just put it to the side. We'll worry about it later. Okay, and now our product rule, we're going to slot everything into this rule here. So our derivative, y prime, is f prime. So f prime first. 9x squared minus 2 times g. So times the second function as is. Don't touch it. Plus the first function as it is. And then the second function, the derivative. That's this piece. I already did this down here separately. You don't need to do it separate. I just did it separately so you would see how it works. Okay, and that's our final answer. Just in case you got lost, this is f prime, this is g. This is f, this is g prime. And finished. You don't need to expand that. We don't want to simplify because you would have to do a lot of work. You'd have to go multiply, 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 multiply. So you would have what, like 20 different expansions, and that's not worth it. The answer is, this is the derivative just as is. So don't worry about simplifying that or multiplying it out. It would be a waste of your time. Okay? So before I move on, hopefully if you have any questions, just let me know. You don't need to worry about interrupting me. I will take your questions at any time. All right? That's always just how I work. But that's the product rule. So we'll do the product rule again, and hopefully those of you that didn't find it easy that time will find it easier this time. So I'll keep the answer there. Given this, so right away, how do we know it's a product? Well, it's a product. It's being multiplied. That's the definition. Product means multiply, so we can see that they're being multiplied. This one is our f. And this second one, and we just need to do our product rule. I'll write it out one more time. F prime g plus fg prime, and follow that rule. I'm not going to do it on the side this time because I want to save space, and hopefully you can see the same thing. This just means derivative, just in case we're not sure. This just means get the derivative. It's another way of writing the same thing. So y prime, or dy by dx, is, I need the derivative of this first one. What's the derivative of the first one? Derivative of this. I see an x, so that becomes 1. How do I know that? Well, same reason that 7x gives a 7, a 1x gives a 1, because there's a hidden 1 in front of that x. And now we have 7 times 2, which is 14x. All right, that's the derivative of the first one. I'm going to write g as is. I'm working my way through the product rule. This is done, this is done. Plus, now I need to rewrite f. Okay, I rewrote f. Now that's done. Now I need g prime. G prime I haven't done yet. This one I need to do as we work through it. So the derivative of 2 is 0. I'm not going to write it. What's the derivative of negative 3x to the power of negative 1? Well, that's negative 3x to the power of negative 2. That's all it is. The negative 1 comes down, makes it negative 3, reduce the power by 1. So it's already negative 1. If we take another 1 away, we get a negative 2. Negative 1 minus 1 is negative 2. So once again, this is f prime g plus f g prime. If you understand your derivatives okay, if you've been doing your practice, this should cause you no issues. If you haven't been doing your practice, then you should be doing your practice. I think I mentioned this. In fact, I'm quite sure I did. I don't think I said it on the recording. The assignment is moved from Tuesday to Wednesday. So it's moved back one day. Gives you a little bit more time to practice. All right, so this would be perfectly fine. You could give this answer. I'm going to expand it out just so you can see that these things do get easier if we try to simplify them. And in this case, it's not too much work to simplify. Actually, this is not enough because it says simplify. You see this? Simplify the result. So if it says simplify the result, I'll make it very clear here. We're not allowed to stop at the step that we stopped at here. We need to keep going because it wants a simpler answer, which means open all the brackets. So that's what I'm going to do. I'm going to open all the brackets and expand this out. So really dy by dx is what? Well, I need to do 1 times 2, which is 2. I need to do 1 times this, which is 3x to the power of negative 1. Then I need to do 14 times 2, so 28x. And I need to do 14x times this, which is what? What's 14x times 3x to the negative 1? That one's a little tricky. It's just 42. But some students aren't sure why that works out the way it does. So let me give you an example. If you have x times x to the negative 1, all right? If you have that case, it's actually x to the power of 1 times x to the power of negative 1. So what we get is x to the power of 1 minus 1, which is actually x to the power of 0. And anything to the power of 0 is 1. So we just delete it. Some of you might be wondering why I'm talking about this. It's because x times x to the negative 1 gives us nothing. All right? So some of you, if you're not quite sure how that works, if you have an x times x to the negative 1, all you need to do is just give it as a 1. Okay, that's my point. Same thing as if it was x to the power of 2 times x to the power of negative 2, they cancel. If it was x to the 3 times x to the power of negative 3, they cancel to 1. So just giving you some basic rules. Okay, let's keep going. That's the first part done. Plus, now I'm doing this part. So I need to multiply things out. I need to multiply this by this. I need to multiply this by this. X times negative 3x to the power of negative 2 is what? Well, I definitely have the 3. Multiply the numbers first. 1x times negative 3x. So 1 times negative 3 is negative 3. And then I'm going to do this work to the side again. You have an x and an x to the negative 2. I want to make sure you're clear with this. X times x to the power of negative 2 is the same thing as x to the 1. X to the 1 minus 2. And what's 1 minus 2? It's negative 1. So this is 3x to the negative 1. I hope I'm not going too quick. I hope I'm making some sort of sense here. I would hope that if you're confused in any way, you will let me know. So where am I? I just did this times this. And now I need to do 7x squared times negative 3x to the power of negative 2. So this is negative 21. And I see here that this is a x squared, and next to the negative 2, they cancel each other. They become 1. So I think I'm done. That was actually a lot of work. If you're not great at algebra, that's going to be quite a lot of effort. But it says to simplify, so you have to simplify it. You need to make sure that you're okay with that. So maybe practice expanding some previous questions. Now, what's our final answer? Let's look and see what can cancel. In this case, I see a 3x to the negative 1. That can cancel with a negative 3x to the negative 1. I have some constants, and I have a 2x. So if I work this out, I see a 28x can remain. And then I have a 2 plus 42 minus 21. That's plus 23. Okay, that's my final answer. Can I just have a general idea in the chat if that was okay or not? Did you get that answer yourself? Do you need me to go through another example similar to this? Is it okay or not? So I see that Abdullah, you're doing okay, but there's lots of you in here today. I want to make sure that it's making some sort of sense. Okay. So by the looks of it, that's 4 of you said it's okay. There's 5 of you. So that's a good fraction. Again, different students have different levels of ability on this, and every student has their own thing that they have trouble with, okay? You might find something the easiest thing in the world, and another student finds it very difficult, but for a different topic, it could be totally opposite, right? So some of you are like, oh God, just move on. It's easy. And other students could really use 5 more examples just like this. So I always want to make sure you have your chance to talk to me, okay? If you ever want to talk to me personally, one-on-one, of course, just send me a WhatsApp, send me an email. I'm always here to help you. Speaking of which, no students have ever come to my office hours. So I didn't know if you didn't know if I don't have them or what. I have office hours every single day at 11 o'clock for 1 hour. I know it's a bit late in the semester to be reminding you, but I do have it. 1 hour, 11 o'clock to 12 o'clock, one-on-one. You can help me. I can help you with whatever you want. And on Sundays today, it's at 1:30. So all you need to do is just send me a quick message, and I'll jump in, and we can do one-on-one help. Okay? So just something to keep in mind. Let's do another question. What is the slope of this curve? So what is the slope of the curve at the function at this point? Can someone tell me the 2-step process that I follow to do the slope of a curve at a point? It's always the same 2 steps. I've been repeating it over and over. Can someone tell me what it is? We've got 2 steps. 1 step, 2 steps. What are they going to be? Anyone remember? I'll tell you. Oh, what
Okay.
is it? You tell me.
First step, we should get the f prime and g prime. Second step, we should put the point, the slope.
Yeah. So the f prime g prime part is part of the derivative. So we definitely are going to do that for product. What I was looking for is if you want the slope, there's really just 2 steps to think about. You need to get the derivative, which will include what you said, f prime and g prime. And then you need to substitute in the x value. And remember, this is the reason that this works is you're given a function. The derivative is the slope. So you have the function, you get the derivative, you'll have a slope function. Put in any x value, it'll give you the slope there. So that's why this works. Find the derivative first and then put in the x value, and it'll give you the slope at that point. So I'm going to go step by step. First step, I need to look at this. This is clearly a product, f and g. I'm going to use the product rule. First step is to get the derivative using the product rule. So my product rule, the derivative of the first one is, and you should be able to do it right here on this line, derivative of the first one is 15x squared minus 12x, right? That's just two power rules. Keep the second one the same. Minus 6x squared plus the first one as is. And then the derivative of the second one. What's the derivative of the second one? It's actually the same thing as in before. There's a bit of a special case going on here, but I'm not going to get into that. You'll see that they're the same. That is the derivative. We've used the product rule. Hopefully you can see that this is f prime g, f g prime. We could keep it like this, or we could expand it. It doesn't matter which one you choose, whether you expand it or not. It'll still work out to be the same answer. So in the interest of showing you how to expand these, I will expand it, but you don't need to. You could go directly from here and substitute. In fact, you can do that now if you want. You should get the same slope. The slope at the end is going to be negative 594. Okay, so I'm going to expand this. And you should do the same. And we'll see what answer we get. Okay, so I'm going to expand. It'll take a minute, but I'm just going to go bit by bit by bit. This is 75x to the power 5 minus 90 x to the power 4 minus 60x to the power 6 x to the power 4 plus 72 x to the power 3. Again, I'm just going term by term, multiplying them together, seeing what I get. 75x to the power 5, 60x to the power 4, 90x to the power 4, plus 72x to the power 3. So this is the full expansion. What you'll notice, you might notice, is that all of these are actually the same as all of these, just in a different order. That's because what we started with was the same function multiplied by itself. We'll get a strategy for working out those later a little faster, but for now, this is all we can do. And let's see, what does this simplify to? Well, we have a 75 power 5 and a 75 to the power 5. That's 150 power 5. Something can almost definitely cancel in here. Let's see. No, they all double. Okay, they're all being added. So our final answer should be this. Sorry, sometimes I just talk through whatever's going through my brain at the time. Many students find it helpful. Some students find it incredibly annoying that I don't stop talking. If you're one of the students who finds it annoying, I'm really sorry. I can't change my voice. My wife says I sound kind of like Kermit the Frog, which I don't know if that's a compliment or an insult. I like to take it as a compliment because otherwise I don't think I'd be able to go to sleep at night without crying myself to sleep. Anyway, so this is our derivative of the original function. Our second step is to get the slope. So when x equals, let's just do a little quick check here. What x value are we putting in here? We've been given an x value. Which value are we actually going to use? -1. Okay, so yeah, when x is -1, that -1 is from up here on top. X equals -1 from up here. Be careful not to use the other values, I guess what I'm trying to say. When x equals -1, what is this answer? Well, the slope, when x is -1, 150. Just be careful when you put it into your calculator, use brackets. Put in the -1. And it should work out okay. So try this yourself. See if you get -594. This is how I would go ahead and do this. The slope at point -1 and 121 is -594. That's our final answer. So I'm going to let you catch up, make sure you get that. And then when you're ready, just tell me on a scale of 1 to 10, once again, how comfortable you are with a question like this. Because this is the last product rule we're going to do for a little bit. We start doing quotient rule review, and then we'll bring it back together. 9. 9 is good. 10 is great. Well, I mean, it's all great. Anything above 6 or 7, I feel okay with. Absolutely, it does take time. What I'll say is, if you want to save a bit of time, you don't need to expand it, right? I'll just remind you that if you want to, you could go right from here and put in -1 to that, all right? You don't need to expand it. The expansion was to just show you something, to just show you that it does simplify, but you can take it, you can take the -1, put it right into the first step, and it'll shorten it a little bit. So maybe that's something you'll be interested in doing. Okay, so I want to show you what this looks like again. And first of all, I want you to understand what the question means. So it says, we've got our answer now, -594. What does that mean? Well, it means that whatever this function looks like, at the point -1, the slope must be super steep in the negative direction. So remember, this is positive slope. This is 0 slope. This is negative slope. And if it's -594, it means it goes down 594 points for every 1 it goes over. So it's super steep. Like if you were walking down this thing, you would have no chance. It's like a mountain, okay? So speaking of walking down something, I'd like to actually graph it. And just bear with me while I do that. I want you to see what it looks like and prove to you that it's matching what we think, or matching what I'm saying. So 5x to the power of 3 minus 6x squared. All right, 5x to the power of 3, 6x squared. All right, let's see, that doesn't look quite right. Is it right? Minus. So this is a crazy looking function. I'm going to squish it down a little bit so we can see what -1 would be. Okay. So this is our function. That's what, it's a power of 6 function. So if you ever get asked, I won't ask you necessarily, but if you ever get asked what the shape of a function is, linear has a power of 1, so it looks like one direction, up or down. If it's a quadratic, which means power 2, so like x squared, it goes down, up, 2 directions, power 2, or up, down, 2 directions. If it's a cubic, which means like x to the power of 3, or x cubed, it would go up, up, which is 3, or down, down, which is 3. In this case, this is a 6. So we expect it to go either up, down, 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 or down, down, up. And in this case, it does. It would be down, down, up, which is why it's like x to the power of 6 form. But you don't need to know that. That's just something interesting. In my opinion, it's interesting. So what is my point? Why did I graph this? I graphed this because we want to know what slope this function has at x equals -1. So let's see, at this point over here. Let me just annotate a little bit. So we know when x equals -1, the slope is -594. It should be super steep. So at x equals -1, what's our slope? It's super steep. The slope is -594. So even though if nothing makes sense to you here, at the very least, you should be able to look at that function and say, yeah, if I was to put a ball on this, it would go down really quickly. Or if I tried to stand on this, I would fall down because it's super steep. And our answer tells us that. our answer is like, what was the slope at -1? And you're like, super steep, man. It's like -594. That's the idea. If you were to put in x equals 0, this function would actually tell you that it's basically flat. It's slope of 0. Or if you were to put in x equals 1, you actually get, I think, the value of -6, which tells you it's really gentle at that point. So the derivative is useful. It tells us how steep our function is at any given point. That might not seem useful right now, but for a lot of applications in engineering and otherwise, it is useful. Some math, not so useful. This math, very, very useful, especially when computers do the work for you. All right, so hopefully I didn't confuse you with that. I was just trying to illuminate, just trying to tell you a little bit more about what we're doing here. But if I confused you, don't worry, I'm not going to make you do that on a test. Not the graphing part. Okay, let's move on to quotient rule practice. I've already done some of these. This is page 37. Sorry if you can hear all that construction. We've just moved in to these places, and it's actually pretty empty. People are just starting to move in, so they're still fixing places up. So hopefully you can't hear that banging on the wall. If you can, I'm sorry. Okay, so it says find the derivative of each of the following. And how do we know that we need to use the quotient rule? Well, that's pretty simple. We look at it and we see, hey, there's a fraction. This is definitely quotient rule. Oops. Quotient rule, we know that because we see fractions. That's what it means. That's the rule. Does someone know what the quotient rule is? It looks a lot like the product rule. It has an F and a G, an F and a G. The only difference, really, it even has the derivatives in the same place. The main differences are we have a minus and we have a big old fraction. That's our quotient rule. Wow, there's that noise. I'm gonna throw a sock. I'm gonna throw a shoe at someone. Where are you? Show your face. Sorry, there's a window right next to me. I'm not actually showing it. Okay, where was I? Let's do this. That's our rule. Our top function is our f. Our bottom function is a g. Let's go ahead and work through the rule of this function. Okay. Y prime, what is it? Well, the derivative of the top, 0, times the bottom as it is, x cubed, minus the top as it is, times the derivative of the bottom. What's the derivative of the bottom? Well, it's x cubed. It just comes down. It gives 3x squared. On bottom, we're just going to keep it like it is, x cubed, and then we need to square that. So this is a case where I would definitely simplify because the brackets are really simple. There's no reason not to expand this out. So I'm going to go one step further. It's not quite nice enough. The first term multiplied by 0, that's going to cancel. The second term here is going to be -12x squared. And on bottom, what's that going to be? This is a little mini test. A lot of students make a mistake on this bottom piece. What's x cubed to the power of 2 is my question. A lot of students have trouble with that. X to the power of 6, because when it has a power, remember that it's not addition, because that was if they're multiplied. This is a power. This is just a multiply, which is indeed x to the power of 6. So just be careful. A lot of students say it's 3 squared, which it's not. It's just 3 times 2. Okay, so this is x to the power of 6. And then let's go one step further. Let's simplify. Remember that the number on bottom, we can just subtract 2. 6 minus 2 is 4. And so we have -12 x to the power of 4. I'm really distracted. There's some real serious knocking going on out there. It's driving me crazy. Hopefully it's not too loud on the recording. All right, so this is this question. I'm going to show you an easier way but hopefully that was clear. Again, just a basic application of the quotient rule, basic application of the fraction. But if you remember back to when we did limits, or at the very beginning of derivatives, I told you to put it in the power form when you could. And this is a case where we can do that. Let me show you. On the side of the page here, let's just rewrite this question. Y equals 4 over x cubed. I'm just going to move over here. I'll come back. Why don't you rewrite it to be this? 4x to the power of negative 3. And if we did that, we could avoid the quotient rule altogether. We wouldn't need to do the quotient rule. We could just do the power rule. So I'm going to say rewrite as power rule, if possible. We'll make it easy. Okay, it'll make it a little bit easier. So let's do the derivative. Do the derivative of this piece. The negative 3 comes down, multiplies, becomes negative 12. And then we reduce the power by 1. What's negative 3 minus 1? Well, it's negative 4. Which, if we simplify that one step further, we get this. Do you agree that that's the better way? That would be the, say, smarter way to do this, or the faster way. It's kind of a shortcut. You're almost cheating the system. Instead of having to use a quotient, you're forcing it to be a power, and then you're just doing it directly. So hopefully you can see that. You're all a little bit quiet today. I'm used to you saying a bit more, but that's okay. No harm done. You can take your relaxing Sunday morning. I won't take that away from you. What I do want to say is that the quotient rule method and the power rule method give the exact same answer. And that's because both are perfectly valid, acceptable methods. Do it as a quotient or do it as a power, it doesn't matter. Do you hear that? I'm gonna go crazy. I'm gonna go through this wall. So hopefully you feel okay with that. What about this one, this next one? Do you want to do B or do you want to move on to 2? If you want a little bit more practice on what we just did, we'll do B. If you want to move on, we'll do 2. B or 2? B, 2. B, 2. B, 2. The answer is not 0, although I can see why you'd think that. Okay. Split down the middle between B and 2. We'll do B quickly. All right, we'll do B quickly. It's not going to be 0. The reason for that is that even though there's a constant on top, that's not how the quotient rule works out. We'll see that it doesn't delete the whole thing. So derivative of the top is indeed 0 times the bottom, which is 5x squared plus 4x. You know, that whole term is going to cancel. That'll go to 0. So that much is okay. But we still have this part, minus fg prime. The minus, what's f? F is e squared. And then we need to do g prime, the bottom derivative. So that looks like this. So this is just the bottom. All right, we've got f prime g minus fg prime, and I've got them in brackets so you can see them clearly. 4 terms. And now on bottom, we have g prime. Just take the whole bottom and put a square on it. Don't simplify. Don't expand this. You're just going to make it more difficult on yourself if you expand that. All right? And now we can write our final answer. If you want to, you can multiply these through. It's not really going to help too much. So I'm just going to write our final answer here. It will be negative e squared outside of 10x plus 4 all over this. All right. So Ahmed, yeah. How is that? Is that okay? I know you wanted one more example. I think the trickiest part of this question, honestly, is just a little bit sneaky. I'll just make a note. Derivative of e squared is 0. Or let me make it more clear. Squared is a constant. I say its derivative is 0. That's something that comes up. You know, if you see e, some students kind of freak out and they're like, oh no, what is this e? It's not a variable, it's a constant. So whenever you see it, just treat it like a 5 or a 1 or a 2 or a 10 or any number. Just know that it doesn't make a big difference. It's just going to simply go to 0. Just want to make a note. Okay. E is a constant, derivative 0. Let's move on. Hopefully that's been enough time. If you need me to go back after, I can show you. Find the derivative of this function. So find the derivative without getting a common denominator. Okay, so how this is going to work is quite simple, actually. It looks like a complicated function. Okay, this function here looks a little bit tricky. It looks bigger than we're used to. But remember, we have this polynomials rule. It just means get the derivative one after the other. So let me show you this. We're going to get the derivative of that. And then we're going to get the derivative of this. And then we'll subtract them. All right? So I'll say get the derivatives one after the other. Get the derivative of one, get the derivative of the other. Don't worry about making them as one big thing. Okay, let's see if we can do this. Q prime is, what's the derivative of 4x squared? Well, the 2 comes down, multiplies, it should be 8x. 8x. That's our green piece. Minus. And now I'm going to start my quotient rule because I didn't want to include 4x squared in all this. So I'm going to do my quotient rule. I'm going to set up one big fraction. And just so I'm clear, this is quotient rule. And this one's power rule. Just two different types of things put into the same question. So the derivative of the top is 1 times the bottom minus the top and the derivative of the bottom. What's the derivative of x minus 1? Well, the 1x, we have an x, which is a 1x. Yeah, it just becomes 1. That's a very tricky one, honestly, which is why I asked it. If y is x minus 1, and y prime is 1. And the reason for that, and good job, Sarah, I saw that, there's technically a 1 there, which is why this 1 is what remains. So be careful. If the 1's not written next to the x, you still delete the x and it stays a 1. It does not go to 0. Some students make sure it goes to 0, which is a problem. Okay, and then the bottom squared. So once again, this is a case where I would simplify this. And the reason I'd simplify is because there's not that much complicated here. This is not complicated. This is not complicated. So we should go one step further to simplify. Let me make it smaller. Now, let's make it easier. 8x minus, this is x minus 1 minus x. All right, this is just a little side note. Let's go one step further, make sure that this is a nice little function. We have 8x. In this case here, we have a x and a minus x. So they'll cancel. You should hopefully see that there is a negative and a negative. Oops. Negative and a negative, which becomes positive. Plus 1 over small squared. All right, so that one's a little tricky because it involves simplifying, but you should be able to do basic simplification like this. You know, if there's a 1 on the outside of the brackets, of course it just becomes itself. You just can ignore that 1. What I'm talking about is this case. You know, if there's a 1 outside, you just keep the second piece. And then the simplification. Do you want me to go back through any of that? There's maybe one step where I skipped with the red, but should be okay if you pay close attention. No questions? I'm a pretty quiet group today. Did you have a busy, tiring weekend, or maybe you're still in bed? I had a very tiring weekend. I had a very, very busy day yesterday. But maybe you'll be happy to know that we're completely moved into our new place. We've got a couple old things in our old place, but we're settled now. This is our new home. So I'm happy with that. All right, let's keep going then. I want to keep giving you practice today because it's fundamental stuff, okay? So let's keep on going. Given that this is true, what is dxy? All right, well, let's just be clear what this means. What is the derivative of y with respect, oops, with respect to x? What that means is that if we have the function y, we're getting the derivative of that, and x is the variable that we're going to be doing all our rules on. So it's the same thing as we've been doing. It means it's a function of x. I just wanted to make sure that you understood that that means the same thing. So all it means is get the derivative. And we can see that this is the quotient rule. We know it's a quotient rule because there's a big giant quotient there. There's a big fraction. So let's go ahead and do it. What's the derivative of the top? Hopefully you can follow. You know, you have 2 times this 2 and reduce it by 1. So that's a 4x minus 5. Keep the bottom the same. If you're getting bored of this, if you're like, oh man, really another one like this, then you are starting to understand. Minus the top as it is. And then the derivative of the bottom is 3 all over the bottom squared. Keep it the same, don't expand. So don't open the brackets for the denominator. It almost never helps. It'll make it more complicated, not less complicated. All right? And it doesn't say to simplify this one, so we don't need to. We can stop there. But for those of you that want to try simplifying it later, if you want, I'll just put or, and I'll write the answer that it would expand out to. So some students want to make sure that they have the simplest version, and there's nothing wrong with that. Okay. So I want to be very clear, and many students who have had me in physics classes know that this is how I do things. I'll often get to an answer that's perfectly fine. You get full marks for it. So that's where I'll put this dash, right? I'm done. So I'm saying I'm finished. My little dashes are there. You can stop there. If I say or, so if I write or, it means if you wanted to give a different type of answer, this is what you would write. So or is another equally good answer, which would also get full marks. So you can stop before the or. You know what I mean? All right, so quotient rule. We just simplify when the question said only. Oh yeah, if the question asks, it says simplify your answer, you must simplify. If it does not say that, you don't need to simplify, okay? Because oftentimes it's enough just to do the direct derivative. Yeah. So for example, in this next question, it says, what's the slope of the curve representing this function at the point 2, -2? So in this case, we have another question that says, what is the slope of the curve at a point? We already did one just like this. The question, the steps are still the same. So the first step is always to get the derivative. The difference now is before we did product rule, this time it'll be quotient rule. And then the second step is to substitute in x. In this case, x equals 2. And I'll just say in general, I'll keep it general, x value. All right? So I'd like you to take 3 minutes or so. Tell me what the answer is going to be. Okay? You need to get the derivative and then put 2 into that. Tell me what that one numerical answer is. And we'll come back and I'll rejoin you in about 3 minutes or so. Anyone get an answer yet? I'm going to start writing out what my answer would be. And we can start comparing. So this would be the derivative. Did we get this far? Did anyone try this question, or you just wait for me to do it? I'm waiting. Okay. That's okay. So the answer has a negative, yes. In fact, the answer, I'll give it to you now so you can compare. It's negative 5/7. There is absolutely nothing wrong with a negative answer for slope. It just means it's downhill. That's all it means. So great job, Aisha. Excellent. That's our first step, is to get the derivative. The second step is to say when x equals 2, what is the slope? So the derivative of p, whatever this p function is, at 2, we need to substitute in a 2 every time we see an x. So I use a lot of brackets. I'm going to just zoom in a little bit. I use a ton of brackets. Every time I see an x, I put a bracket. And the reason for that is if it's ever negative, you won't make a mistake. More importantly, when you put it in on a calculator, it won't mess you up. But some students find that very confusing. So just You got to get used to it, but it'll help a lot. So I'm just going to show you. 2, 2, 2, 2, 2. So that's all of my x's have been replaced by 2's. And if you work that out, either slowly by hand or slowly by calculator, you should get -5/7. So Aisha was the only one who got that, or at least who showed me the answer. But that's how you get it. The first step is worth most of the marks. And I mean that like a step for the derivative, another step for this derivative, a full mark for using the quotient rule, a mark for substituting in the answer, and then probably a mark for getting the answer. So this is how I would mark this. Each derivative is usually worth 1, or maybe sometimes, depending on the question, it's worth 1/2. But this is how I mark this stuff. So the derivatives are very important. The substitution step is just that, it's substitution. So how are we doing? It's a bit of a quiet group today. You're all alive out there? I don't need to worry about you, do you? Do I? You doing okay? I'm going to assume that you're doing okay.
Mr.
Yes.
Sorry. About in the left, up in the left, 6x minus 4x. We can say like it's 2x.
You're talking about this, yeah?
And 2 and 2, like 2x 2 plus 2. Not right.
What are we talking about?
I didn't multiply. I just like add them together.
You mean for this 6x?
Yes, I moved the practice.
Okay. Here, you're talking about this.
Yes.
It's still 6 times 2. I mean, because if we look at this 6x, no matter what way you put it, you still need to multiply by 2. Whether you put the brackets or not, you're still replacing the x with a 2, which is the multiply.
Okay.
You can't add the 2. If they're touching, they multiply.
Okay.
Anyone else? Okay. All I'll say is that make sure if you're using your calculator for this, be very careful. The nice thing about using the brackets, and the reason I use the brackets, is because instead of hitting multiply every time, you can type it exactly like I wrote it. The Casio knows that if you have brackets touching, they multiply automatically. So you don't need to worry about all the extra stuff. You just put it in directly into your calculator like I write it, and it will give you the answer. You know, you could even try, just type this in your calculator, it'll give you 12, for example. Just a little piece of advice. Okay, so let's move on. I want to do some more chain rule. I'm going to scroll down just a little bit. Page 39 we did at the end of Thursday's class. I'm going to move on to page 40. I know it doesn't help you, Ahmed, but hopefully you've made sense of your notes by now. You can always label them in the bottom. Practice. Find the derivative of each of the following. All right. So the chain rule, in case you've forgotten what the chain rule is. Is you do, if you want the derivative, y prime, you get the derivative of the outside, you keep the inside the same, and then you get the derivative of the inside. What it means is if we have a composite function, or a function inside another function, we work from the outside and then go inside, and keep doing that until we're finished, okay? So in this case, we say find the derivative of the following. This question 1a, its form looks like this. It looks very similar to this with a function inside for x. So what I would normally do is I wouldn't want to do a quotient rule on this. It would be way too much work. So bring it to the top. Rewrite it as this. Okay? Just bring the bottom expression up and change the sign of the exponent to negative. I'm going to do that. I want to rewrite. and write it as this. T squared minus 2t minus 5. Then we have to the power of -4. And then if you rewrite that, you have that as a -4. That's way easier because once it's in power form, we're good. So we're going to rewrite in power form is what we did here. Form. All right. Now, what am I going to do? I need to do the derivative of the outside. We'll bring the power down, keep the inside the same, and then do the derivative of the inside. I'll show you what that looks like. Some of you, this will be a review, important review. So let's take this down and reduce it by 1. So we have -4. The inside will stay the same. Doesn't matter what's inside, just keep it the same. And then I'm going to reduce the power. -4 minus 1 is not -3, it's -5. -4 minus 1 is a -5. And then, this is the part that many students miss. We're not done. Right now, we've done the derivative of the outside. We haven't even done a derivative of the inside, and that's not okay. We always have to get the derivative of every piece. So we need the derivative of this. What's the derivative of that? Well, you should hopefully know by now. It's 2t minus 2. And that is our chain rule. That is how it works. You get the derivative of the outside first, and then get the derivative of the inside. So this would be okay. It's not a great answer, but it's not simplified, but it would be acceptable. Before I move on, any questions on that one? Just a review of what we did last time, but I wanted to make sure I reviewed it. I'm going to put an or because it is important that we are able to simplify these sometimes. So if I need to simplify, I'm going to do two things. I'm going to take this -4 and I'm going to multiply it by this. And then I'm going to bring the fraction down by changing that power. I'm going to do two things at once. I'm going to take this and multiply it by this, okay? That will give me -8t plus 8. And on bottom, I'm going to have this expression. But we want positive powers when we finish. So instead of having a -5 here, I'm going to bring it down on bottom and make it positive. And that's a better version. But again, both of them are okay. You're allowed to write either one. Ah! Okay. Again, I don't mean to go too slow, but it'll reach a point that I have done enough of these, and I'll eventually do one that's suddenly difficult, and you'll be like, oh, crap! I wish you'd gone slower so I knew all the steps. So that's why I go slow. I want everyone to be able to follow. So those of you that are at like the tippy top of the class, getting like 80s, 90s, and 100s, I apologize if this is too slow for you, but just feel good that you're at the top of the class. And the downside of that is sometimes you have to be slowed down so that us regular mortals can catch up. Okay, so let's move on. Shouldn't we change all the signs? So your question is a good one. The difference is we only change signs on the top. So if you have a negative in front, so I know you're talking about this negative, right? In front of the -4. That negative only affects things on the top of the fraction. And because I'm moving this piece to the bottom, it will not change signs, okay? Another way to know is that if it has a square, if it's inside a bracket, it's kind of locked in there. We don't touch it. So the only thing that changes sign is this piece here. So in other terms, in other ways, this negative is going to be distributed to those only, not the bottom, all right? There's a lot of, what I find about this stuff, some students, by the way, they find this their favorite topic. And I'm one of those people. I actually find this calculus to be my favorite part of math. And if you like it, you'll be happy that the next course is almost exclusively calculus. In fact, it is all calculus. So if you find this easy, you'll really enjoy the next math course. But the problem is it goes back and has to use all of these other math rules that we haven't seen in a long time, your basic algebra. So make sure you get the practice and you'll be okay, all right? Let's do another question. Let's do question B. So the first thing I'm going to do is rewrite it because I want it as a nice power. So that will give me, keep the inside the same, that power of 5 is a square. It looks like a square root, right? So normally we'd have this square root would be something to the 1/2. If it was a cube root, it would be something to the 1/3. Well, this is a power 5 root, so it's the power of 1/5. That's how these powers work. In fact, square roots are a hidden 2, but we almost never write the 2. Okay, so we've rewritten it. It's now a nice power. What are we going to do? We're going to bring it in front, keep the inside the same, get the derivative of the inside. That's what the chain rule does. So the chain rule says we have 1/5 in front. It doesn't even matter what's on the inside. We're going to reduce the power. So I'll just keep the inside the same. And I'm going to give you a little trick for simplifying. I'm going to move this out of the way. For simplifying the power, all right? When you do derivatives, you're only ever subtracting by 1. So the trick is take the top number, subtract the bottom number, and you'll have your top number, okay? What I mean is 1 minus 5 is -4. So just say -4/5. It works because of the way the common denominators will work. So once again, it's just 1 minus this 5 is a 4, or -4. That's the fastest way to do it. You don't even need to use a calculator. Okay, where am I? What am I doing? Okay, yeah, I need to get now the derivative of this inside. So the derivative of this is, let's see, 3. So this would be a case where you definitely want to simplify because that 3 is just so simple to simplify. So let me go one step further and do a simplification. Derivative is, I have a 3 on bottom and a 3 on top and a 5 on bottom. It's going to look like this. That's one way to simplify it. I'm going to write an or so that, different students have different ways they like to simplify this. I'll write out different ways. This is also acceptable. I could probably even come up with a different way if I thought hard enough, but these are your standard ways. Questions? Just going to clean up this page a little bit. Clear? Again, this isn't even using product rule or chain rule or quotient rule. It's just chain rule. So hopefully it makes some sort of sense to you. We're soon going to extend it, but for now, we'll just keep working with the basics. Let me know if you ever need to go back or if I've gone too quickly, anything like that. 2, find the slope of the tangent to the curve. Find the slope of the tangent line. So normally this is our two-step process. First step would be get the derivative. Second step, we'll just substitute in the x value. But in this case, even though it wants the slope, it actually didn't give us a point. And so it's a little easier question. We don't have an x value given. So there's no x given, just get the derivative. Easy peasy, lemon squeezy. I would like you to try and get that, which will take you about 1 minute. And I want you to just type it in the chat just to make sure that you're still alive. You don't need to simplify it, but you can go ahead and simplify it if you want to. All right, give it a try. Did anyone get this far? Okay, so this would be the shortest possible way, and you could leave it like that, but it wouldn't be so good. The reason is this is just a constant, and this is a really simple function. Like, don't worry about the one with the power, but these parts in purple right now are really easy to simplify, so it's best that you do simplify them. So if you see something that's easy, a basic simplification like that, you should go ahead and do it. So multiply them together. 4 over 3 multiplied by 6 is 8. So you get 8x. 4 plus 3x squared, power of 1 over 3. And that would be enough. So not many of you are in the chat today. Maybe some of you just turned on the class and left the computer going. I don't know. But hopefully this makes some sort of sense to you. Hopefully you're getting it. Ayesha, excellent. That looks like the right answer to me as well. The only other thing you could really write it as, and most students would not do this, but some students do, is that's a 1 over 3, which is also a cube root. So they write this out, they put the root over it, and they put a little 3 there. And that's also equally acceptable. It's the exact same answer. Okay, so it's up to you if you want to write it like that. I prefer this way because sometimes the root is not helpful, but if it asks you to fully simplify, that's what we'd have to do. Okay, so that was a quick one. I'm going to leave 3. I'm not going to cover 3. That's just something you could do for homework. You just still substitute in. I'm going to move on to mixed derivatives. Let me see. Actually, I'm going to just go to the next page. I'm going to start on number 4. Okay, number 4. Find the derivative of this function. We have this 18 outside. This one we've done one already like it actually. I'll just say it's for homework. All you need to do is take this 18, bring it in front, and then you need to do the derivative of the inside. So I'm not going to worry. I'm not going to do that one. I'll leave that for you. I will do the next one because it's a little bit longer, a little trickier looking.
Mr.
See it. Yep.
Sorry. Can we go up, please? In the, 3. We have to do B and then A, right?
Yeah, I guess you do.
Yes.
I don't know what I've written like this. Yeah. So you would, let me see if there's some other way. No, Okay, so this is slightly different. I'll write out what we need to do. I'm not going to do the whole thing because we did one like it before, but just as a reminder.
Okay.
So for A, first thing you do, you get the derivative, and then you would sub in the x value. That whole process gives the slope, okay?
Okay.
That'll just give the slope, or m. That's your first step. For B, remember you have to do your process where you need to solve y equals mx plus b.
Okay. Okay.
You'll put in this will be 1 over 25. This will be 3. Of course, this would be from part A. And you need to solve for B, yeah?
Okay.
So in other words, solve for B and write y equals mx plus b. We've done ones like that before. I can do it for you now if you want, but I think there's other things I should be working
Oh,
on.
no, it's okay.
The full solutions are online. You can check it if you want me to go through any of it. Just let me know. I'll go through it next class.
Thank you.
All right, let's try this because I think this is good practice. Given this function, f of g of x, so this composite function, or in other words, given this, what's this? So this just means the derivative. So get the derivative. That's all it's asking. You don't need to worry about the crazy notation. You can be careful, but you don't need to worry about what it means. It just means derivative. So the derivative of the function, derivative of f of g of x with respect to x. So in other words, it means the same thing as y prime. It's the same thing. What's the derivative? Well, you take it piece by piece. So let's just say this is our first piece. This is our second piece. And this is our third piece. So I'll try to write it out matching the colors. The first one would be this. Bring the 3 down, keep the inside the same, and then do the derivative of the inside, which is 2x. That's my first piece. My second piece, which is this red color, is going to be this. 4, keep the inside the same, reduce the power, it's just 1, and then the derivative of the inside. 5, the derivative of 5 is just 0. So these are my 3 different pieces. 3 different derivatives. They all use the chain rule, but I'm not going to re-explain how to do the chain rule because we've been doing it, right? Just be very careful that it's the derivative. That's pretty much it. We just need to do a little simplification and we'll be done. So I know that I should simplify because look, this is just a 3 and a 2x. That's really easy to simplify. This is a 3 and a 4 and a 2x. That's really easy to simplify. So I'll just simplify it. This is 6x outside of that. And this is 8x outside of this. And there's no need to go any further with that. That will be our final answer. How do we feel about that one? That's a slightly longer one, but really it's just 3 questions in one. 3 little questions in one. I'll take the silence as a yes. Easy, okay. So I'm glad it's easy. That makes my heart feel good because when this was first taught to me as a student, my teacher was horrible. I probably said this before. My teacher was terrible and I had no idea what was going on. And so I never want that to be your problem. So if you ever have trouble with it, even if you find it easy now and you forget it later, don't be afraid to tell me. I'll go back through it with you. As long as it takes, I just want to help you out. I'm going to move on from this section. Number 4, you can just do on your own time. Again, they're all similar difficulty, really. Some of them are more challenging, but I want to move to mixed derivatives. And what I mean by mixed, and again, this is page 42. What I mean by mixed is it's not just one type. You're going to have your basics. So you might have your power rule. You'll probably have product rule, quotient rule, chain rule, and they're all in the same question. You'll have to do all of them in order to answer these questions. And sometimes they can get extremely difficult to keep track of what part we're talking about. And so that's why I wanted to make sure that the basics were covered, and now we can work on slightly harder problems. I'm not going to say that they're more difficult. They just look way harder. They look way more complicated. It's the kind of stuff that you might see scrawled on the board in Big Bang Theory. Or like, you know, in math course, you'll be seeing things like that. You get this integration symbol, but yeah, it looks big. It's not too scary. So let me try to make it as simple as I can. So we're applying combinations of the above rules. Let's look at this and see what we need to apply. So right away, I definitely see a chain rule. And the reason I know it's a chain rule because I see it's y equals x cubed form. I also see that it's quotient rule. The reason I know it's a quotient rule is because I see a fraction. And that's about it. I'm obviously going to need to use the power rule as well, but that one's an easy one. Okay, so how am I going to approach this? Am I just going to do it directly? Do I need to simplify first? What do you think? I think in this case, there's really no simplifying we can do first. We can't like divide it. We can't flip it on top or anything like that. So we're just going to need to dive in and see what happens. So the derivative is, let's take the power, bring it down in front. Comes 3. Keep the inside the same. Even though it's complicated, we still keep the inside the same. And then, just like normal, we need to get the derivative of this piece. How do you get the derivative of just that piece? It's the quotient rule. So it's like you start again. It's like we're saying, hey, what if this was the original question? Can you get the derivative? And at this point, I hope you would say yes. So this gets really big. I'm going to make a giant bracket, and I'm going to start my process. Okay? Now this is my quotient rule. I did the derivative of the, oh, I'm missing something. 2. Sorry about that. Let's do our quotient rule. I'm not going to write out every step this time. I'm just going to show it clearly. We have the derivative of the top, 3x squared plus 4x, times the bottom, minus the top, times the derivative of the bottom, -1, all over the bottom squared. So I'll write this. This is f g prime g squared. Done. Don't simplify it. No need to simplify. You'll just make a mess. That is the derivative. This is one of those problems that you like show your mom. You're like, hey, I could do math. And she thinks it's real complicated. She's like, what even is that? I can't even read it. And you're like, yeah, exactly. You can't read this, but I can. This is the derivative of a function, sucker. Anyway, this is the final answer. Looks super complicated, but really it's just piecing things together. So on a scale of 1 to 10, how's that one? We're going to do more like this. C will probably haunt your dreams for a while to come, but I think this one's okay.
Mr. Can we say that like x cube multiplied by 3 and 2x squared, we would like for each one of the inside the brackets, we put cube.
So what I would say, you're talking about dealing with this, yeah?
No, up.
This.
You simplify the 3, the power 3, inside.
No. You mean you want to do like, oops. You want to take this and try to distribute it like inside?
Yes.
That won't work. And the reason is that that's not how powers work. Let me show you how the power would work. Because this is a good question. A lot of students try to do the same thing. Remember what a cube means is multiplied by itself 3 times. So what you'd actually have to do is you would have to write it out once, and you'd have to multiply it by itself. Oops. And then you'd have to multiply it by itself again. And you can see that that's not the same as just bringing 3 down. It doesn't work like that. So we definitely do not want to simplify first. If it has a cube on top or a 4 or a 5, never simplify it first. If it has a 2, maybe, but not a 3, not a 4, not a 5, okay?
Okay.
That's a really good question. You would be amazed, or maybe you wouldn't. I'm always amazed how many students try to do what you just said to do. And it does not work. It'll never work. Powers don't work like that. All right, so I'm going to move on to B. And hopefully we can make some sense of this. In B, just looking at this right away, I can see that it's definitely a composite function. So we're going to have chain rule. Because I can see I have all of this inside of something to the power of 11. So it looks like this. That's the form. So we can do the power, bring it down, subtract, all that stuff. I also see a product inside. So we're going to also worry about the product rule. And that's, you know, our product inside, and we're going to need to do f prime g plus f g prime to figure that one out. All right, let's just jump in. We can clearly not simplify this by the same reason I said before the octet. We can't just take this 11 and like distribute it. That's not how these powers work. So we have to do directly. We just have to do the power rule first. We're going to take this 11, bring it in front of the whole thing, and then reduce it by 1. We have 11. Keep the inside the same. All right, it looks like this. Whatever's inside, do not touch it. Do not change it. You're just going to make a mess for yourself. Just keep it the same. X minus 7x cubed, 14 plus x squared. And I will write the colors out just so that we can keep track. That's really all I've done. I've just done the blue stuff. Now, we need to do the product rule on this. Because we need the derivative of the inside, that's how the chain rule works. We need to do the product rule to do that. And I'm going to make a big bracket again so that we don't lose it. And we basically start the question again. We need to get the derivative of this, which I think all of you can do by now, or at least those of you that are still here paying attention. I think some of you in the chat, or some of you in this, are probably not even there. You just signed your computer in and went away. But, you know, hopefully you're still there. So the derivative of the first one is 1 minus 21x squared. Keep the second one the same. Plus the first one. And then the derivative of the second one is 2x. And once again, we're not going to simplify that. We're just going to leave it like it is. Hopefully you can see, I'll put it in green. This is f and this is g. So this is f prime g plus f g prime. And that is done. How about that one? I feel almost silly asking because I keep getting no replies. But is it okay? Are we getting to a point where we're confused yet, or we still feel fine about it? If this was in class, I mean, if this was in person at the college, it's much easier. I just say, how's it going? Thumbs up, like this, thumbs down. Unfortunately, we're at a bit of a distance here. I think we all are ready to go back to the college, but I don't know when that's going to be. I don't even know if we'll be back by the fall, but I hope so. So Ahmed, you said, but this is not the last answer. Yeah, for this one, for B. Wait, what 11? What about your 11?
I mean, you should put the 11 outside and put the power 10.
I have that.
Oh, okay. Oh, I got it.
Yeah, so this is finished. I did the outside and kept the inside the same, and then I did the derivative of the inside right here. Those are my two big pieces.
Like,
Sorry, did you have a question? I can't tell if you just asked a question or not. Gonna move on, okay? I don't know if you just, I don't know what you said. Okay. Let's do C. This one's a beast. This one's intense. And the reason is, I'm a little bit scared by it actually. This one, this is going to be product rule. The whole bottom means that we need to do quotient rule. So we have a product rule on top and a quotient rule on bottom. Overall, if we look at this whole piece, it's one big quotient rule. Which means we need to get these pieces. Derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. The problem is the top is its own product rule. The top is F. And in order to get that F prime especially, that's a product rule. So this will end up being a giant answer. In fact, it's so big that I don't even think I'm able to fit it on the page. I'm going to try, but let me try to make this as clear as I can. All right, let me shorten that. And let's see if we can work this out. Let me try and think of the easiest way to do this. Okay, this is what I'm going to do. On the side here, in my notes section, I'm going to work out. Sorry, I'm trying to think of a way that makes this as easy as possible for you. I don't know if there's much way to make it simpler. I might just have to go directly. Just give me a minute so I can see if what the best strategy is. There's maybe 2 or 3 ways to do this. I'm just trying to think what I did when I did my notes before for myself. What's the easiest way? I think I'm just going to do it. Let's see. All right. The top, and we need the derivative of the top. The bottom, and we need the derivative of the bottom. Because this is one big product rule. Sorry, one big quotient rule. This is going to be our top. This is going to be our bottom. Okay. The top is large, but not complicated. I'm just going to rewrite what it is. The top is F. This is the biggest question probably in the course for derivatives. I would never ask it on an assignment or a test, but it's important to at least know how it would be done because it makes sure you know how to do product rule and quotient rule. So I've written the top. Notice that I rewrote this as this, just to make it easier, powerful. I'm going to do the derivative of that in a second, but I want to rewrite g first. So g is x minus 9 plus x to the power 5. The derivative of that is what? Well, 1. Negative 9, derivative of that is 0, so 5x to 4. All right? So that's my regular g prime. It's f prime that's going to cause me problems, okay? Do you see why this is going to be a problem? The whole fraction, I need to do quotient rule, but the top is a product. So in order to get the derivative of the top, I need to do a product rule inside the quotient rule. So you can see how this gets big. Let's go ahead, I'm just going to go to the side here. I need to get the derivative of this. This is again going to be like a new f and a new g. And our product rule is derivative of the first one of the second, plus the first one, derivative of the second. So I'm just going to do my regular pieces. Derivative of the first one is 8 plus 27x squared. The second as it is. Plus the first one as it is. Times the derivative of the second one, which is 6x plus 20x to the power 4 minus, or sorry, plus 3x to the power of negative 4. You see what I mean when I said this is going to get big? This is just one small section of the overall question. This is f prime. Fg prime. And those are our new f's. So you could almost say like f2, g2, but you don't need to worry about that. I'm just trying to split it all up. So just to recap, we have one giant quotient rule. We're trying to do it. It's easy enough, f prime, f, all that. We just needed to get f prime, and that's a product rule in itself. So I'm going to piece all this back together. And it's going to be gigantic. I hope you can still read it. So my quotient rule is f prime g minus f g prime over g squared. I'm going to move this over so I can actually look at it. I might need to move it again, but I'm just trying to make it easier. Okay. It begins. Let me try to shrink this down, actually. Sorry, I don't mean to be annoying. I'm just trying to keep it all as much on one page as I can. Okay. So f prime, I need f prime here, the blue one. 8 plus 27 squared. I'm just copying this piece. 3x squared plus 4x to the power 5 minus x to the power of negative 3 plus 8x minus 4 plus 9x cubed 6x plus 20x to the power of 4 plus 3x to the power of negative 4. That's just f to the power of f prime. I'm going to use square brackets to separate it. And now I need to multiply it by g, which is the bottom. So I've now done f prime and g. I'm going to do minus. I need to write f again, which is the top. That's f. And now I need to write the derivative, which is 1 plus 5x to the power 4. So I'm going to shrink that down just a little bit so that it can all fit on one page. Sorry for those of you that are still writing. All right, what a mess. Now, yeah, isn't this intense? All over the bottom squared, which you just need to rewrite the bottom and put a square on it. And that's the end. Have you ever seen an expression that big in a math course? I highly doubt it. That is probably the biggest that you've ever seen, but that's what some of these expressions look like. Again, I would never ask you to do that on an assignment or a test unless it was a bonus question, but each piece is actually not that complicated. I'd expect you to be able to at least understand it. This is, again, the kind of stuff that looks really impressive. So when they do shows like Big Bang Theory and so on with a lot of math, they just grab things that look like this. They look really complicated, but it's not as bad as it seems at first glance. How's that? We only have one short example left to do and we'll be done. I'll end on an easier example. Can you all read my writing? Is it going to be that long? Do you mean if I asked you on an assignment or a test, would it take that long? Or do you mean, can we like simplify it, or what do you mean? No, I wouldn't ask you one this long on the assignment. No. On the assignment, it would be a shorter version. This is just showing you how these things can get big if I choose them to be. All I need to do is add an extra little tiny term and it'll make it giant. So I'm not going to give you that. At most, it'll be a bonus. You would expect more like A and B is what you should expect, okay? Or this last one. So I want to finish this one. It should only take me maybe 5 minutes and we'll be done. I just want to end off with an easier example. So find the slope of the function at x equals 1. So once again, derivative. Second step, substitute. What I'm going to say first is that we want to simplify it. I'll make life easier, okay? So first things first. This, let me show you this. If we look in on this, if we divide this and this by x to the power of 3, it'll cancel that. This will become a 2, and this will just become a 1. So it looks like this. X squared minus 1. This piece here, this is one case where we can multiply everything by the 3, or sorry, simplify it out. Becomes 8x cubed, that's 8x to the power of 6. So we expand that. I'm doing this quickly because I don't want to waste too much time. I'm expanding it first. The reason I'm expanding it first is because it would take forever to do it any other way. So what I want to point out here is that when you look at this, we could have done it as a giant product rule. And it can be done that way. But whenever possible, it's a really good idea to expand it first. Yeah. So I'm just going to put this off to the side. Sorry, my computer is fighting me today, as usual. That's just simplifying. And now I'll do my 2 steps. So first things first, get the derivative. I want to get the derivative of this piece, which is just 80 x to the power of 9 minus 128 X to the power 7 plus 48 to the power 5. That's my derivative. I don't need to do anything else. My second step is to do what I normally do, which is to substitute the x value. So when x equals 1, what am I going to get? I'm going to say, when I put the 1 into y prime, well, you just put a 1 in. You just end up with 80, 1, 128, 1 to the 7, 48, 1 to the 5. Yeah, you do all that work to get a 0. So at the end of the day, this crazy complicated function, when x is 1, is flat. If you were to put a ball on it, it would just stay right where it is. And that would be the end of this question. You can do this question by doing a big product rule, but it's better that we don't. It's easier this way. Okay? Halas, we're finished. I'll stop the recording here. Tomorrow we'll move on just to the next page, implicit differentiation. If you have any questions, let me know. Okay, bye.